heartbeat follows rules written in symbols we claim we invented. So here's the disturbing question. Did humans create math, or did we accidentally discover the operating system of existence? People often say mathematics is something humans invented, like we invented games, alphabets, or currencies. We made the symbols, the equal signs, the strange letters, and that part is true. But the deeper question is this: did we also invent the relationships those symbols describe? Imagine no humans ever existed. Stars would still burn, planets would still orbit, and objects would still fall toward the ground in predictable paths. The universe would continue behaving in orderly patterns without anyone there to calculate them. When we later write an equation for motion, we are not forcing nature to follow our rules. We are recognizing a rule that was already happening perfectly. What's remarkable is not that we can describe reality with mathematics. The remarkable part is how precise the match is. The same equation works today, tomorrow, and on the other side of the galaxy, it works for a falling apple. Behind them is not. We didn't create the curve a thrown ball follows. We noticed it. We didn't design the ratios inside waves. We measured them. So mathematics is like discovering a coastline. You can draw the map yourself, but the land existed long before the map maker. Most descriptions humans make come after events happen. We watch, we record, and then we explain. But physics does something far stranger. It writes the explanation first and reality follows later. An equation in physics is not just a summary of past measurements. When the equation is correct, it allows you to predict something nobody has ever observed. You can calculate a value, build an experiment years afterward, and nature will quietly confirm it. The universe behaves as though it was already following those instructions before we ever discovered them. This is deeply different from memorizing patterns. If you watch 1,000 waves in the ocean, you may guess how the next one moves. But mathematics lets you predict the motion of a wave in a place you've never seen under conditions that have never occurred before. The prediction doesn't rely on what energy will appear when matter changes form. And when the experiment is finally done, the numbers match with unsettling accuracy. So mathematics and physics is not merely descriptive like a history book. It behaves more like a discovery tool, a way to uncover pieces of reality that exist before we encounter them. The universe somehow is predictable before it is experienced. Look around you for a moment. Objects don't randomly change weight every second. Light doesn't decide to slow down on Tuesdays. Causes reliably produce effects. Without that stability, nothing could exist long enough to form atoms, stars, or even your thoughts. Reality survives because it behaves consistently. Now think about what consistency means. If the same situation produces the same result, there must be a rule connecting them. And if a rule works everywhere and every time, it can be expressed as a relationship. Mathematics is simply the most precise way to write relationships. So mathematics is not imposed onto nature. It appears whenever nature refuses to contradict itself. Imagine a universe where the laws change dependable behavior. From that dependable behavior come patterns, repeating motions, conserved quantities, balanced interactions. From patterns come ratios, symmetries, and numbers. And those become equations. In other words, mathematics is what consistency looks like when described clearly. We didn't decide the universe should be logical. If it weren't, observers like us could never arise inside it. So when we discover mathematical laws, we are uncovering the minimum order reality must have in order to exist at all. The equations are not decorations on the universe. They are the evidence that the universe holds together. Many people worry that explaining the universe with equations removes its magic. They imagine that once you know the law behind something, the wonder disappears as if mystery were the only source of beauty. But the opposite happens. When you don't understand something, it feels impressive because it is confusing. When you finally understand it, it becomes impressive because it is elegant. Instead of chaos, you see order. Instead of coincidence, you see connection. The amazement doesn't across an entire planet. The explanation doesn't replace the experience, it enriches it. Physics does not turn the universe into machinery. It reveals that the machinery is graceful. A few compact principles can describe oceans, stars, electricity, and even the matter inside your body. The mind begins to recognize that nature is not complicated for the sake of difficulty. It is simple in a very precise way. So knowledge does not close the door to wonder. It moves the wonder to a deeper level. Instead of asking, why is this strange? You begin asking, why is this understandable? And that is a far more powerful mystery that a small human brain can grasp rules vast enough to guide galaxies.